and heats of reaction, finally getting around to define what actually the heat of reaction is, we need to discuss the symbol for heats of reaction, the units, and define what we know to be a thermochemical equation. So the definition, which would be given word perfectly by you in an examination situation, is the heat change when the number of moles of reactants indicated in the balanced equation for the reaction react completely. Okay, that's a big kind of definition to understand. So if we break that down, very simply, the heat change. There's going to be a heat change. Next up, when the number of moles of reactants indicated in the balanced equation. So that says to us we'll have an equation, it's got to be balanced, and the stoichiometry or the molar number of the reactants is given. And the last part there, for the reaction, react completely, i.e. 4 moles of X reacts fully with 5 moles of Y. Now, our symbols. Delta H. Delta H will show us that there's a heat change, and our units are kilojoules per mole. Now with delta H, we could have two values. We can have a negative value if delta H has a minus sign in front of it, so a minus number or a negative number. That means we have an exothermic heat is given out. If it is positive, it is an endothermic reaction, which means the heat is pulled in. The kilojoules, or kJ, are the SI unit for energy. So, a thermochemical equation. Now, a thermochemical equation is a balanced chemical equation that includes physical states of reactants and products and the enthalpy change, delta H. Again, that's an awful lot to take in. So let's take it very simply and think about it for a minute. In this, it says physical state. So that means your state symbols have to be in your balanced equation. For example, if it's H2, we know hydrogen is a gas, so you'd have a little G beside it. If it was H2O, you'd need to have L beside it. If it was a liquid, or if it's in its vapor form, you'd have to have a G beside it. Now, be aware that a physical change is required because changing the physical state can alter the value of delta H. That's very important to be aware of, okay? Guys, that's everything around defining what a heat of reaction is. We need to remember delta H is the state symbol, or is the symbol for the heat of reaction. The units are kilojoule per mole, and we need to be comfortable describing what we know to be a thermochemical equation. If you guys have any questions on that, please do let me know. Remembering that in this case, the physical states of reactants and products must be given. That means we need to have state symbols in our equations.